So welcome to part 2 of our unit on chemical and physical changes. And in this particular part here, I'm going to start showing you the difference between those two. So up until now, we've really been focusing on just the chemical changes. Remember last time I described that what we're calling a chemical change is what, before break, we just were calling a chemical reaction. So I showed you a few examples of that. We did things like write the equation for those different reactions. And so we'll kind of start with that and summarize that again. But then I want to contrast the chemical changes with physical changes and kind of tell you how to tell the difference between them. Because that's my main goal for you, is for you to be able to read the description or look at something and tell me whether it's a chemical change or a physical change. Okay? So we'll just title this chemical versus physical. Remember, you should write along with me here, and if you need to pause me or slow me down, hit the little button down at the bottom that slows down the speed, or just pause as you need to. Okay, so chemical versus physical changes. So if we start with chemical, and here's the key. You'll know it's a chemical change when new products are formed. Okay, so these are going to be different than the reactants. Or I'll say it this way, maybe I won't use the fancy science word reactants. Different than what you started with. The English teacher wouldn't like me ending the sentence with a preposition, would they? So you start with one substance and you end with a different substance. Okay, so we've seen that time and time again. In my last set of notes, I wrote the equation for photosynthesis. In photosynthesis, you start with two sort of raw products, carbon dioxide from the air and water, which the plants would have water nearby, getting up probably through the roots, right? Or maybe it rains on the leaves or something. Those are the two reactants. When we're done with the photosynthesis reaction, we have something entirely different. We have, actually it's a solid, although it's probably dissolved in the water inside the cell, but it's called glucose. It's a huge molecule, very, very big. It's got, 24 different atoms in that one molecule. So that's glucose, and the other product is an oxygen, a diatomic oxygen molecule, O2. Okay, totally different. Same atoms, but different ways of combining those atoms to make up different substances, right? And that's how all the different substances of the world are made. We usually start with raw materials and we do some kind of reaction and we get something different in the end, okay? So what are some examples of some chemical changes? And again, many of these we've named already. So here's one, rusting. You start with a nice hunk of iron. If you leave it sit out for a while and you come back later, it doesn't look like a metal at all. It's not hard and shiny, silvery colored. It's sort of red and powdery. That's rust. Totally different material, right? Have you seen silver after it sits in oxygen, or if it gets wet after a while? And I'm talking about real nice silver. It will tarnish. It will turn like a black color. That's a silver. I think it's silver sulfide or silver oxide. It's a different material. It's got the silver atoms in it, but it's a reaction with the oxygen in the air, and I think some of the other things in the air. Burning. Obviously, after you burn something, it looks totally different than before. Wood turns into ash, right? Paper turns into ashes. White bread in the toaster, if you leave it in too long, it turns into black, kind of not too tasty stuff, right? You don't want to eat it. If you hear something decomposing, that's a chemical change, okay? Breaks down, right? Or rotting, very similar kinds of processes. If you leave food in the fridge too long, or if you leave it out on the counter, or somebody forgets about it in the back of the fridge, and it turns into something kind of gross, that's not the same stuff you had before. Totally new substance, which means that was a chemical change. Okay, so there's several examples of things that you'll consider chemical changes. Now, how about the physical changes? Okay, in this case, you have the same substances, but it's in a different form. Sometimes you might think you have new stuff, but you don't. Okay, so listen as I describe some of these processes to why it's not a chemical change, but just a physical change. How about if you bend or break something, like glass, right? You can break glass, but it's still glass. Or if I take a piece of plastic and I bend it, it's still the same plastic, right? So a change of shape, right? How about if I change the size? So still the same stuff, right? But I can maybe shrink it. I could take maybe a foam ball and I just squeeze it and fill in all those air pockets. It's still the same stuff, right? But it might look very different. I could flatten it, right? So any change of shape or size considered a physical, not chemical change, okay? You could mix with other substances. Now, as long as those substances don't react with each other to turn into something new, it's considered just a physical change, okay? For example, dissolving. If we have salt, typical table salt, and you know what salt tastes like, right? That's one of the few chemicals I think most people have tasted before. If you dissolve that in water and you mix it up, all that does is it changes the size of the little particles of salt, breaks them down into such small pieces that they're not visible to your naked eye anymore. And so if you tasted that salt in the water, it would still taste like salt because it is still salt, okay? So we haven't changed the substance into anything. If we mix, sprinkles into your ice cream, they're still sprinkles, right? They haven't reacted with the ice cream to turn into something new. Anytime you change the state of the material, okay? So what I mean by state is solid, liquid, or gas. We call those the three states of matter. Just changing one of those does not change it into a new material. The easiest example is if I take water and I put it in the freezer, it cools down, changes temperature, it's still water, and eventually those water molecules they don't have as much freedom to move around when they get cold like that, and so they kind of get stuck in place. Now you do notice that usually you trap some air in there. That's why ice cubes look cloudy and not clear like the water that you put into the freezer. But it's not anything new. It's still H2O molecules. They're just stuck in place a little differently, right? And so a change of state, such as freezing water, is only a physical change, not a chemical change, right? If you melt it again, what do you have? You have the water right back again. This is a good test of whether something's chemical or physical. Usually, a physical change is reversible. So if you melt something, you could freeze it again. Or if you freeze it, you could melt it again. If you bend it, you could bend it back. If you break it, you could reassemble it, although that's not always the easiest thing in the world, right? If you mix something together, you could separate it again. For example, that salt water I mentioned, if you let that water evaporate out of your salt water, you're left with just the salt. Okay, it would take a long time probably to evaporate all the water away from a cup of salt water, but if you did and let it sit long enough, you would have salt residue in the bottom of the glass. That's how you know you never did change what you had there, okay? So you're not reacting the salt with the water, right? You're simply mixing them together and changing the size of everything, All right. So those are all examples of physical changes. All right. So again, the key difference is, oh, look at this. I just noticed. I'm looking at my screen. When I talk and try to write at the same time, sometimes my hand doesn't move quite like it should. This should say substance. And I wrote substancing. Now, you were thinking 5 minutes ago, what did he just write there? But same substances in a different form, okay, or same substance in a different form. If you have a new substance, that's when it's a chemical change, all right? Okay, so there's the key difference between those two. We'll give you a little chance to practice identifying those. We'll see how that goes. Make sure you have your notes complete before you move on.